Welcome. Thank you for joining me for the continuing 8.5 notes, factoring trinomials. Now, the other day when we were working on this, what we started working on is when C was positive. Now, today we are going to focus on when C is negative, so when C is less than 0. However, before we start working on that, what I would like to do first is recall what have we discussed. So again, discussing when C was positive, what did we end up with? Well, we end up with a factored form that looked like this: x plus a number times x plus a number. Or if the x term is negative, you could have x minus a number, x minus a number, because two positives multiplied to be a negative, or two positives multiplied to be a positive, and two negatives multiplied to be a positive. So today when we're transitioning, and now we're going to be thinking about C being negative, that last number being negative. Well, we need to consider, how do two numbers multiply to be negative? Well, all that means is we're going to have x plus a number and x minus a number. It means that the two factors we're looking for, one is going to be positive, the other is going to be negative, because that's the only way to multiply to get that constant term to be negative. So let's practice this skill. Let's take a look at how this looks. So again, what I'm seeing here, the first thing I notice, my C is negative. So I already know right off the bat, I'm going to have x plus a number, x minus a number. I can already make that skeleton, okay? And so now we need to consider ways to multiply to give us negative 15. So we are talking about 1 and 15, 3 and 5. And of course, understanding that one of those must be negative. So we're either talking about negative 1 or 1, negative 15, negative 3, or 3, negative 5. So now, because of that negative, we're getting kind of double the options going on here. But our end result is still going to be the same. Now that we've paired all the ways to multiply to give us negative 15, our goal is now to find, well, which one of those adds to give us that positive 2. So if we run through our options, negative 1 and 15, well, that adds to 14. That's not going to give us what we're looking for. Negative 3 plus 5. Oh, there we found it already. Negative 3 and 5 adds to give us that 2. So we're going to have x plus 5, x minus 3. So again, this is going to be essentially the same as what we did yesterday. Just now we have to make sure we're taking into account that one of our numbers can be negative. So let's continue looking. Let's look at example A. So here, I'm noticing again, I have a negative C value. So I'm going to create this structure, this skeleton. So we're going to have n plus a number and n minus a number. And again, I can already see that because I'm talking about that negative 36. The only way to multiply to give me that negative 36 is a negative and a positive. So let's start running through ways to multiply to be 36. So we can have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So here we have a lot of options to getting 36. Now again, the key here is we know one of those numbers has to be negative, okay? So as we're running through this list, we know either those have to be negative or the other in each pair must be negative. All right, so we have a lot to run through here. So let's start trying some of these out. -1 plus 36 gives us 35. So that's not going to give us the 9 that we're looking for now by adding them together. Now, if you notice on the other side, 1 and -36 gives us just the opposite, gives us -35. So once you cross off 1, all you need to know is, are you looking for the opposite or not? And if it's not the opposite of what you're looking for, you can actually end up crossing off both on the list. So again, -2 and 18 adds to 16. Well, the other side would just give us -16. So we know neither one of those are what we are looking for. -3 and 12. Oh, those add up to 9, don't they? So I found the two numbers that multiply to give me -36 and add to 9. So now all I have to do is fill those in. N plus 12 and n minus 3. All right, now I need to erase a little bit of that to give myself some more space for this next one. For this next one, same thing. I'm seeing a negative C value. So I know when I'm breaking it apart into two factors, we're going to have a negative and a positive. So when I make my skeleton here, I'm going to have C plus a number, C minus a number. And I'm going to run through my options here. So to multiply to give me 21 is 1 and 21, 3 and 7. And of course, hopefully we're catching on. We have the understanding that we know one of the numbers in each pair must be negative. So that really represents our complete options here. So let's begin. -1 plus 21, well, that gives us 20. So not the -4 that we're looking for, which also rules out the other one because the other side would just give us -20. -3 plus 7 gives us a +4. Well, +4 isn't what we're looking for. However, it is -4 that we're looking for, which means it's going to be the other side of that one. So 3 plus -7 gives us that -4 that we are looking for. So all I have to do is fill in that chart. All right. So here to summarize, we're going to do this together as a class when we get all together. Because here's something, a really good conversation I would like us to have. So I'm going to have a skip ahead and work on these examples together. So factor each expression. So again, this is going back to the basics. Now, I do want you to realize this is kind of accumulating everything from the first notes and today's notes. Because look at this. Here, I have a positive C value. So a positive C value means I'm looking for either two positive numbers or two negative numbers. Because my B value is positive, that's telling me that I'm looking for two positive numbers. So I can create my skeleton to look like this because I've already determined I'm looking for two positive values. Now I need to take that 12 and I'm going to break it down. And I'm breaking it down by saying I'm looking for two things that multiply to give it to me. So 1 times 12. 2 times 6, 3 times 4. So those are the three options we are looking at. Once we break it down, now we need to see which one of those add to 7. And if you notice, it's going to be the 3 and the 4 that add to the 7 that we are looking for. All right, looking at the next one. So the next one, to analyze the situation here, we have a positive C value again. So we know how to multiply to be positive. We're looking for two positives or two negatives. However, look at this negative 13. Because the B value is positive, or the B value is negative. So the only way that this can work is this time we have to have two negative values, R minus a number, R minus a number, because that's the only way to multiply to be a positive C, but a negative B value. And now I'm going to focus on that 42, numbers that multiply to give me 42. Well, we're talking about 1 and 42, 2 and 21. We're talking about 3 and 14. And we're talking about 6 and 7. So those are all the combinations of ways that you can multiply to 42. However, we've already had the conversation that we know we're looking for two negative numbers. So we know that's what our focus is going to be. All right, two negative values. And now I need to run through, figure out which of those pairs is going to add to give me that negative 13. So as you're running through your options, you will come to find negative 6 plus negative 7, or if you just think of it as negative 6 minus 7, gives us that negative 13 that we're looking for. So this is going to be R minus 6, R minus 7. All right, looking at our next one. So p squared plus 3p minus 40. Now, the first thing I'm going to hone in on is that minus 40. What that minus 40 is telling me is I need two numbers that multiply to that. Well, to have two numbers that multiply to a negative number, that means I'm going to have a positive and a negative. So I can already tell you that much about this problem. So I'm going to begin breaking it down now. So numbers that multiply to 40. Well, we're talking about 1 and 40, 2 and 20. 3 doesn't divide 40, but 4 divides 40. Oh, I apologize. 4 and 10. 5 and 8. Then 6 doesn't, 7 doesn't, and then we actually wrap back around to 8. So these are the ways we multiply to give 40. However, we've already discussed, we know we're looking for a negative and a positive because it's the only way that we are multiplying to a negative number. So we're looking at either these as our options or these as our options. One of our numbers in each set must be negative. So, looking at this, now that we focus on that negative 40, now we need to focus on how do we add them to get positive 3. So, I'm going to run through my list. Negative 1 plus 40 is 39, which is not what we're looking for. Also, we're not looking for the negative of that, negative 39. Negative 2 plus 20 is 18. Well, we're not looking for 18 or negative 18. Negative 4 plus 10 is 6. Well, we're not looking for 6 or negative 6. But here we go. Negative 5 plus 8, that is giving us our positive 3. So the two values we're looking for here are p plus 8, p minus 5. All right. So now I'm actually going to skip ahead. I'm going to skip number 4 for now. We're going to do that as a class later. What I would like to focus on is number 5. The area of a rectangle is given by the trinomial n squared minus 3n minus 28. What are the possible dimensions of the rectangle? And it's telling us to use factoring. Now, it's not let's use factoring because we know if we're looking for length times width to give us area, we need to break that up into two things that multiply to give us that polynomial. So, to factor this, the first thing I'm going to look at is do my sign analysis. So, negative 28. I need two numbers that multiply to negative 28. Well, I know right off the bat, two numbers to multiply to be negative. I know I'm looking for a positive and a negative. So I already have the skeleton of what I know my solution is going to look like. Now I start brainstorming. Things that multiply to 28. Well, 1 and 28, 2 and 14. 3 doesn't work, but 4 works to give 4 and 7. 5 doesn't work, 6 doesn't work, and then it wraps back around to 7, which we already have. So those are the options to multiply to negative 28. But now we've already had the conversation. We know one of them is going to be negative. So we know really this is what our options look like. One of our numbers must be negative. And now we need to find which one of those pairs adds to negative 3. So let's start running through our list. Negative 1 plus 28 gives us 27. We're not looking for that or negative 27. Negative 2 plus 14 gives us 12. Well, we're not looking for 12 or negative 12. Negative 4 plus 7 gives us 3. Well, that means we're looking for the opposite of that. So our answer is going to be right here. 4 and negative 7 give us the negative 3 that we are looking for. So n plus 4 and n minus 7 gives us exactly what we are looking for. All right. So to wrap this up, tell whether the sum of the factors of the constant term should be positive or negative when you factor the trinomial. So, the sum of the factors. So, what those are really asking us are the sum of these two numbers. Well, as you know, the sum of those two numbers comes from that middle term. So really, all we have to look at to see if the sum of the factors should be positive or negative, for each of these, all we really have to look for is that middle term. So in number 6, that middle term is positive, so the sum of those factors should be positive. Number 7, the middle term is positive, so the sum of the factors will be positive. Number 8, it is negative, so the sum of those factors is going to be negative. All right, and then for our reasoning, under what circumstances should you look at pairs of negative factors of the constant term when factoring a trinomial of that form? Now, this is something we've already discussed, so I'm going to leave this as food for thought for you. So we have those couple of things we're going to wrap up together as a class. So I'm leaving you with thinking about number 9, okay? So we can begin class with a conversation of that. So thank you for joining me. Make sure you have all of these written down, and I'll see you in class.